Hello, and welcome back to the Ninox Learning Channel. My name is Andy. I'm a Ninox trainer and programmer. And in this class, we're going to continue our discussion of looping and repetitive decision-making constructs in the Ninox language. Previously, we looked at the if-then loop, which allowed us to instruct Ninox how to make decisions given its evaluation of a set of circumstances. After that, we looked at the case or switch statement. This allowed us to instruct Ninox what to do when faced with any number, a large number of situations. It could evaluate the situation and act accordingly. In the most recent class, we looked at the while-do loop. This allowed us to execute a repetitive set of actions or functions as long as a current state was true. As soon as the situation changed and the statement or the current state was false, the repetition of the loop would end immediately. In this class, we're going to look at the last of the four major looping constructs, the for next loop. This is a powerful piece of code that allows us to act on entire tables or subsets of tables called arrays. Now, during the course of this class, you're going to see me working with a database that has a number of buttons, a couple of tables, and a lot of examples of the for next loop. If you would like a copy of this database, you can download it for free at our website. Simply go to www.nioxus.com. That's Nioxus.com. If you already have a free password, click on Login. If you don't have a password, it only takes a moment to get one. It's completely free, and you can get it by clicking on this button. Once you have your password, click on Login, which will take you to the Nioxus member portal. Go into the templates section, and you will see a template called Using the For Next Loop. That database can be downloaded, it's unlocked, it's not password protected, and it will allow you to look at and utilize all of the samples and examples you see in this class today. And as long as you're there, you can check out lots of global functions that you can copy and paste into your Ninox databases, data models, and all of the Ninox Learning Channel videos. But enough about that, let's get down to business. Now, the for next loop, this fourth looping structure, as the name would imply, allows us to loop through or repeat over and over and over again a series of steps or instructions or functions that we can apply to a set of data records. Now, when talking about a set of data records, we're talking about something that is called an array, A-R-R-A-Y. An array is a collection, a set of records within a certain table or a specific table within our database application. The array can be as large as every record in the table. It can be as small as one specific record among hundreds, thousands, or millions of records. But very often an array is a subset based on some criteria. All customers within a particular state or country, all invoices that are above a certain amount, or all events that took place between two dates. In this class, we're not only going to look at the for next loop, but we're going to look at how we can use that looping structure and apply the functions within that loop to subsets or arrays of data that we can identify and quickly extract out of any table in any of our Ninox databases. Let me first show you a couple of for next loops in action so you can see the power and see the capability of this structure. And then let's take a deeper dive and see how those loops are built so you can create them for your own use in your applications. As always, feel free to hit pause at any time, practice right along with us, and don't forget, you can download all of the samples you see in this video at any time and also at no charge. So here we go. We have created a very simple database. We'll start by looking at the data model. 4 tables set up in 2 families. Both families store customer invoice information. We have this family here called Open Invoices, which consists of the invoice header and then the line items within that invoice. We have an identical family here called Paid Invoices, again with a header and the line items for each invoice. Invoices in the Open Invoices table have not been paid, and once they have been paid in full, we want to move them, the header and all of the associated line items, over to the history table. We're going to use a for next loop to do that. Let's see this in action. I'm going to go into Open Invoices, which you can see is empty, and as long as we're here, the paid invoice or invoice history table is similarly empty. We're going to go into Open Invoices and create a very basic, very simple invoice 1001. The customer will be the Acme company, and I'm going to go ahead and create a couple of line items. We're going to sell them item 1, a quantity of 50 of those at £10 each. And then I'm going to create a second line item, which we'll call item 2. We're going to sell 10 of those, and those cost £450 each, or £4,500 for a group of 10. So we have one invoice, invoice 1001, with 2 line items, 50 of one item and 10 of another, bringing the total due on this invoice to £5,000. When I click this button, Post Invoice, watch what happens. The invoice is gone. There's no invoice in the Open Invoices table. In the Paid Invoices table, there's the invoice. And we've used a darker background so you can easily see the difference between when we're looking at the history table and when we are looking at the Open Invoices table. Let's do this again and watch slowly as we go through it. Another invoice, this one to the Smith Company. Now this time, instead of adding one line item at a time, I'm going to ask Ninox to just create 2 line items for me by typing in the number 2 and clicking Create Line Items. 2 line items instantly appear. This one will be item A. We'll sell 1 of those for £1,500. And this one will be item B. 1,500 of those at £1.50 each. Let's go ahead and create another invoice. Invoice 1003, back to Jones Incorporated. I will create just a single line item for item 100, and we're going to sell 25 of those at £25 each. Now, while we were off creating invoice 1003, the Smith Company paid invoice 1002. We now can go in, post the invoice. Invoice 1003 from the Jones Incorporated company is still in the Open Invoices table. But if we go look at paid invoices, there's 1001 to the Acme company, which was paid a little while ago, and there's the invoice we just posted with all of the line items intact. Now, how did we do it? Everything you just saw was done using a for next loop. Let's start with the posting process, the Post Invoice button right down here. I'm going to create a new invoice. We'll start with a new numbering schematic, 2500, so we can easily find this invoice. And this one will be to the Brown Partners LLC. I'm going to create 2 line items and fill them each out one at a time. Item 1 with a quantity of 10 at £100 each, and item 2. quantity 15 at 70 pounds each. Now what we want to do is move the contents of this header record, or what we call this open invoice, and these two records in the invoice line items child table. What you see on screen, what appears as one invoice, is actually two tables. The header table, which is the customer name and the invoice number, and the child table, or the invoice line items, and there are two. So we have three records, one parent, two children, spread out across two different tables that need to be moved to two other tables. And this post invoice button is going to do the job for us. Let's look at how this works. As I mentioned, it does use a for next loop, but just very quickly, let me show you what we've built here. We have created a couple of variables. The current record variable stores the ID of the invoice we're looking at now. These two variables store the values in the invoice number and the customer field. We then create a value, I, a variable I, and we assign to that variable the key number, the index number of a newly created paid invoices record. Paid invoices is the name of the table where we keep all of our invoice history, all of the invoices that are closed because they have been paid in full. The instruction to Ninox is to create a new record in that table and assign that unique identifier, the Ninox ID number, to the variable I. Now, referencing I, we then assign the values to the two fields in our newly created history record. I, indicating the key of the record created, and the invoice number field is equal to the invoice number of this newly created invoice. That number is stored right here. This is the invoice number in the current table. The current table is the unpaid or open invoices table. We store the invoice number here in this variable, and then once we have created the record in the history or paid invoices file, we use that variable to move the number into the invoice number field in the history table. We use the same design mechanism of putting the customer name into this variable, and then once we've created the new record in the history table, the record indicated by the I, the variable I, we then insert the customer name as it existed in the open invoice table into the field customer of the closed or invoice history table. So all of this up here, all of this code line 1 through 6, allows us to create the header file. No loop is required, nothing has to be repeated, because there is only one record to be created. But now we need a loop. Now we need to repeat a specific process because of those two child records, those two line items that are associated with the invoice that we just moved out of open and into the paid invoices or the invoice history table. We have to repeat a series of actions, and the number of times that we want them to repeat is equal to the number of records in the child table that are associated with the parent. Or more specifically, we want this loop to repeat once for every line item record, every line item child record associated with the invoice parent record. There were two line items, so we want this loop to cycle through 2 times. As is the case with all of the looping structures, the if-then, the case, switch, and the while do, the loop begins with the name of the loop, for, and of course it's always in lowercase. We then define a variable, the variable j. Now, you will note there is no statement that starts with let that defines the existence or brings to life the variable j. We don't need one. When you are using a variable as a counter, and we'll talk about what a counter is in a moment, when you are using a variable as a counter within a for next structure, the for statement not only initializes the structure, it also brings to life or brings into existence this variable, which in this case is called j. You, of course, can use any variable name you want. We then say that for the counter j in this array, this is the subset or subselection of records, a selection of line items, specifically the line items which we see right here in the child table in our sidebar. We want j to be a counter, and we want it to count from 0 to a number equal to the number of records in a selection of line items attached to this invoice. How many line items were there on this invoice? There were 2. So how many records are going to be in our selection? 2. Which means this for next loop is going to cycle through twice. For the first time, it's going to do all of this on the first record in our selection. Then it's going to go to the next record. And for the next record, it is going to do the exact same set of instructions. It will not execute a third time because we have specified that it is only to loop, only to repeat for the number of records in our selection. And our selection is simply the number of records in the child line item table. What it then does is for every j, for every count, for every one record in this selection, it will create a blank record in the line item history or history line items table. It will assign the unique ID of this newly created record in the line item history to a variable called h. And again, the let statement initiates h as a valid variable. H now is a pointer. It is pointing to the new record, which is currently an empty record, in the history line items table. That record has 4 fields that must be filled in, and the values that go into those 4 fields in the history table are equal to the values in the same corresponding fields in the open invoice table. And those fields are the item, the quantity, the price, and finally the invoice history or the reference field that links these line items back to this current invoice. So again, let's review the structure and syntax of the for next. It begins with the keyword for. For does 2 things. It initiates or opens the looping structure and brings a variable to life. In this case, the variable j. Now, the nature of the for next loop is we define how many times we want the loop to repeat. There's a number of ways we can do that. One of the most powerful and most frequently used is to define the number of times a loop, the for next loop, is going to repeat by virtue of the number of records in a selection. Remember, the selection of records is called an array of records. Just think of it as a subset. If all of the apples on the tree are all the records, then the few that we pick off the tree and put into our basket, that subset of apples in our basket, that's an array of apples. Similarly here, we are selecting out of all of the records in the line items table, only those, we are picking only those associated with this current invoice. The other invoice, which has its own line items, those line items will remain untouched. So we have our array, our subset. This statement, using the keyword select, not only picks the subset of records that we want, but it counts them automatically. So this statement, select line items, actually equals a number. It equals the exact number of records that have been selected. So what we're saying is, for J into do the following 2 times, and J will be the variable we use to keep track of whether we're on the first pass or the second pass of the loop. Every time the actions have been completed and we hit the end of the looping structure, J will be increased or incremented by 1. So, in the beginning, J starts at 1. We are executing on the first record of the 2 in the array. We do all of this to the first record. We effectively move it, we copy it or duplicate it from the open invoices table to the invoice history or the paid invoices table. Then we hit end, so we increment J by 1. J was previously 1. 1 plus 1 is 2. 2 is not greater than the number of records in our selection. Therefore, when we hit line 13, we will increment the counter J by 1 and return back, loop back to line 7, where we will repeat this set of instructions, but this time they will be applied to the second line item, the second child record in our array or selection of line items. We then will once again arrive at line 13, which is the end, the conclusion of the for next looping structure. And again, the variable J will be incremented by 1. J at this point equals 2. 2 plus 1 is 3. It will return to line 7 and say, wait a minute, 3 is greater than 2. J is only allowed to get to 2 because there's only 2 records in the counter, in the selection or array of line item records. And because we have exceeded the number 2, this loop will immediately stop, and we will then go to line 14, the first line after the conclusion of the looping structure that copied all of the line items for the invoice that we moved from the open file to the paid file. Here we find yet another for next loop where the number of repetitions is going to be equal to the number of records in an array, in a subset or a subselection of records in a table. We are starting a new loop, so we see for the second time the keyword for. This time we're initializing and using the variable D as our counter. And D, that counter, is going to repeat a number of times equal to the number of records in the selection. But look at how this selection is a little different. In this selection, we selected all of the line items in this table, the line items table right here. All of the line items in this table that were tied back to the current invoice. In this case, we are selecting all of the line items where the line items are tied back to the current record, and what we are doing is deleting them. Up here, we moved them into the history file. Now, for each one of them, and there are again 2, we are deleting them. D points to the record, and the keyword delete is our instruction to Ninox to remove the record that is being pointed to in the variable D. Now I'll tell you a couple secrets. First of all, we could have taken this line and moved it right up to immediately after line 12. So what would have happened is we would have copied the line item record from the open line items to the paid line items and then immediately deleted it. And the second thing I will tell you is this for statement and this for statement do exactly the same thing. They return exactly the same number of records, which is the number of line items in the line item child table that are tied to or linked back to this customer invoice parent record. What I wanted to demonstrate, however, the reason I did this in 2 separate loops is to show you that you can select by virtue of a link. Select all line items where the line items table is linked as a child to the parent, or your subset, the records you select, or the digital apples you pick, if you will, are selected out of a table where a field within the record contains a certain value. There is a field in the line items table called invoice header. That field points to the parent record. It contains the key ID number of the parent of these child line items. That value is stored in a variable called CURR capital REC, current record. So, all line items, select all line items where the number in the invoice header reference field is equal to the number of the invoice we are currently looking at. This ability to define the qualifications for being included in the subset by virtue of values in a field is giving us lots of flexibility. We may have a list of 1,000 customers, and we want to select all customers in one state or in one country, or maybe that exist or do business in a specific continent. We also have conjunctions like and or. We can use those conjunctions to create complex selection criteria. For example, let us say we have a database of students in university, and we want to select all students who are under the age of 21 who are currently enrolled in a specific computer programming class. We could write a statement, select in the table that has the names of all of our students. Select all records in that student table where their age is less than 21 and their class schedule includes a specific class. Using the and conjunction, combining it with the where function of the select, allows us to create very specific subsets of data. And when we combine our ability to extract or mark these subsets of data in the tables, when we combine that with the repetitive nature and the counting structure of the for next loop, this is a very, very powerful combination of features. So to review, we took the one record that was the header and we duplicated it in the history. We then went through a loop, a number of times equal to the number of records in this selection, the number of line items linked to the current record. That was 2, so we repeated this loop twice. And this loop duplicated or copied the child line item record over to its counterpart, this newly created line item in the history line items table. We used this field to make sure that the line item in the history table pointed back to or was linked with the parent record, which was created here in the paid invoices table. We ended the first loop and immediately went into a second one where we selected all the line items where a specific field contained a specific value, and for every line item record we found that met that criteria, we deleted it. We ended the second loop and then finally deleted the current parent record. Let's see this again in action. Remember that invoice that we created while the other invoice was being paid? Here we are in open invoices. A long time ago, at least it seems like a long time ago, we created invoice number 1003. I now post it, executing this loop, which duplicates the records in the open files, the header and the child, into newly created empty records in the history files, the history parent and the history line item or child table. We click the button, they are duplicated, moved over to history, and eliminated or deleted from the current open table, and there it is in history. There's 1003, there are our line items. So what we've learned so far is we can use a loop to repeat itself automatically based on the number of records in a selection. The selection can be as big as every record in a table, as small as one specific record, or somewhere in the middle based on criteria we set within the select statement. Let us look at a different form of the for next loop. And that is the form that allowed me to create a new invoice, define a number of line items, click one button, and have all of those line items created for me automatically. Remember, one of the key features of the for next loop is we get to tell Ninox how many times to repeat the loop. In this case, in the create line items button, I have told Ninox to do this, to create a line item in the line items table and link that line item back to this current invoice. How many times? The number of times it takes to go from 0 to the value in the field number of line items. And note, in this case, that number was 4. So, to see it again in action, I created an invoice. This time, let's create 20. I want 20 line items to be created automatically when I click this button. So what I am telling Ninox to do when this button is clicked is to make note of the unique key number of the current invoice. Then count from 0 to the number of line items, in this case 20, and for every one tick along that count, 1, 2, 3, all the way up to 20, do the following. What I want you to do is create a new blank record in the line items table, assign the pointer or the identity of that new and now empty record to the variable J, and then the field in that record called invoice header should be given the value of the unique identifier of the current invoice. What I'm saying is we created this invoice up here, and we want these 20 line items that are about to be created to be linked back to this invoice. Click the button, and there's our 20 line items right there. We can only see 6 at a time, but I promise you there are 20, and if we want, we can go down and display them all like that. So there's all 20 of our line items. We now can go into each line item and fill it out as we see fit. Now, I don't want to fill out 20 line items. I'm going to go back and create these 4. So this is invoice 2501 to the Jones Company. Item 1 is a quantity of 100 units at 5 pounds per unit. And again, the reason it's at the bottom is because we currently have this being sorted numerically from low to high, and the blank fields are showing up first. I'll go ahead and add item number 2 in the quantity of 200 at a price of 25 pounds each. Item 3. Again at 25 pounds, and item 4. And of course, folks, I'm making up the information that you see me typing in now. It can be anything you want. I just want to get some information in here so we can process some of this data. So here we have a single parent record. That parent record is identified as invoice number 2501. That parent record has 4 line items, where we have items 1, 2, 3, and 4 being sold in various quantities at various prices to this customer, and the extension is simply the quantity times the price. The invoice total is all of the extensions added up. We created these 4 line items using a looping structure where we used a parameter. Here, this field is acting as a parameter where we can go in as the user and define how many times the loop should repeat at runtime. We did not have to go into the code. We simply refer to this field as the number of times the loop should repeat, and for each repetition, we create that blank line item. Now, remember that table that I created a moment ago with those 20 line items that I really don't want to take the time to go fill out one item at a time? I want to keep this parent record. This is going to be invoice number 2502 to the Franklin Institute. I want to keep this, but I want to get rid of these 20 line items. This button right here, when I click it, does exactly that. It removed the 20 line items associated with this invoice. But you will note that the line items for invoice 2501 and the line items for invoice 2500 remain untouched. They were not deleted. This button, delete line items, also uses a for next loop. For, and we define the variable I. In a selection of records out of the line items table, records where they are pointing back to the ID of the current record, the linked field in the child line item table is called invoice header, and for every record in the line items child table where the invoice header field contains the number of the current invoice that we are viewing on screen, delete it. So here we again see this for next structure being used in order to apply a function, in this case the delete function, to a subset or an array of records. I can now go back, I can create the 2 line items that I actually want. I can fill those line items out accordingly and be at 200 at 20. Now, while I was creating that invoice 2500 got paid. Let's post it. 2501 and 2502 untouched. They were not part of the selection. If I go back and look in my paid invoices history table, there's 2,500, line items intact. Now I go into the open invoices, 2501 got paid. Let's process that into history. Similarly, 2502. My open invoices table is now empty. My paid invoices or history invoices are now filled up. All of the data was moved from one set of tables, the parent and child, to a different set of tables, the parent and child for the history. Now let's quickly review the different forms of the ForNext structure that we've seen. And then before we end the class, I want you to see a couple of other variations of the ForNext that have their own unique capabilities and function. Again, looking at what we've seen so far, remember that a ForNext structure is a repetitive looping structure where we, the end user, have the ability to define the number of times the loop will repeat. That repetition, that number of repeats, can be based on the number of records in a selection or an array. That selection can be as big as all records in a table, or it can be very specific based on the values in specific fields of records in a table. And don't forget, you can have multiple fields serve as the criteria by linking them together with the AND statement. Select all of the records in this table where this field equals this, and that field equals that, and a third field equals a third parameter. So you can be very specific in the selection of your arrays, those subsets of data. We saw another format of the ForNext that was a counter, starting at 0 and ending at a number that we defined at runtime. And by that I mean we defined it while using the system, not by virtue of opening up administrative mode and modifying the code. We typed in a number here, for example, 10, and this button ignites or initiates the repetition of a loop for a number of times counting from 0 to this value 10. And what that loop does is creates new records or new line items in the child table. So here we saw a different variation of our looping structure where we set the beginning and the ending number for the loop, and it counts in ticks of 1. First, second, third, 5 times, 6 times, 7 times. And when the loop is executed a number of times equal to the value that immediately comes after the to statement, the loop will stop, it will end, and pick up execution at the next line of code after the end of the loop, or in this case, if there is no line of code, the entire code block will stop running automatically. I want to take this opportunity to look at a couple of other looping syntax structures, a couple of other options that we have in the ForNext loop. It's a very flexible looping structure. Now we've seen this one where we want to repeat this process a number of times equal to this many records, which in this case is all of the records. Select all of the records in this table and count from 0 to that number, and for every record change the value of the current status field to this value closed. We've seen this before. The number of repetitions is equal to the number of records in our selection. Here we see it again, but our selection is more specific. Again, we're initiating or initializing a variable I, and we are saying repeat this loop from 0 to the number of records in our selection, but instead of selecting all records in the invoices table, only select records where the value in the status field is equal to capital O PEN. And for all open records in the invoices table, do the following. Change the status to closed. We've seen this function, but it's in a new form. Repeat this loop, repeat this process this many times. Count from 1 to 100. Count this range, starting with this number and ending with that number. And for each number along the way, 1, 2, 3, 98, 99, and 100. For each stop in the sequence, print the invoice, the record in the invoices table that has that number. So in this case, it is going to print invoice number 1. Then it's going to print invoice number 2, and then 3, all the way until it is printed invoice 98, 99, and 100. When it attempts to increment the counter I by 1, and that result exceeds the maximum number of times the loop can repeat, when it is run 100 times and it ends the 100th repetition and attempts to do it a 101st time, the loop will not execute, because it can only execute when I is between the range of numbers at the low end of 1 and the high end of 100. So we can define ranges hard-coded, as you see here, or this could be a variable. And here we see yet another format. The variable I will equal every number in the sequence, starting with the value in the field first invoice and ending with the value in the field last invoice. So for example, I may want to print all invoices starting at number 250, ending at number 300. In the field called first invoice, I would put the number 250. And in the field called last invoice, a numeric field obviously, I'd put the number 300. I is going to assume the value of every number between first invoice, between 250, and last invoice, 300. So for every invoice numbered between 250 and 300, we're going to print that invoice. And here we see yet another version of the first last, where we can define the starting number and the ending numbers for the loop, but we can add a step. So for example, if I want this loop to start at invoice number 1000 and end at invoice number 2000 in steps of 2, I is going to equal every other number between 1000 and 2000. It's going to equal the number 1000, 1002, 1004, 1006, all the way through 1996, 1998, and finally 2000. It's going to jump in steps of 2. That is going to be a series of invoice numbers. All invoice numbers, all even numbered invoice numbers between 1000 and 2000. J is going to equal the identifier of that invoice. Find the invoice where the invoice number is equal to the value of I. And the value of I is going to start at 1000 and go to a maximum of 2000, skipping to every other number. So only even numbered invoices. And for every one of those invoices, it is going to print that record. So the additional feature we have when we set using the from, go for a number of records from this to that, and we have the added ability to skip numbers. If we have 100,000 invoices and we want to print every 10th invoice, we would go from 1 to 100,000 in steps of 10. I would equal the numbers 1, 10, 20, 30, 40, all the way up to 100,000. And for each value inserted in I, we're going to find the invoice where the invoice has that number. We're going to point to that invoice using the variable J, and then we're going to print the record that is being pointed to using the variable J. So this class was all about the for next loop and our ability to repeat a series of statements across a series of counters or ticks, with the end statement increasing our counter by default by 1, or if we've defined a step, by that value, and doing the instructions inside the loop every time the loop repeats. We can repeat a loop a number of times equal to the number of records in a selection or an array, or we can repeat a loop a number of times between two values. Here we are repeating it between the values of first invoice and last invoice. Here we are repeating it a number of times equal to the number of values between 1 and 100,000 in steps of 10. So there's all different ways to use the for next statement. The important thing to remember is your for next structure not only allows Ninox to repeat a set of instructions over and over and over again, but it allows you to define the number of times that repeat will happen without having to go into the code. Now, the last thing I want to remind you, now that you have all 4 looping structures in your toolset, now that you have at least a basic understanding, don't forget you can mix and match and combine. We can put if-then loops inside of for loops. So for example, we may have a looping structure that says for I in select invoices do the following. If the customer name for that invoice equals Smith Brothers Hardware Store, then do something. Maybe change the name, the customer name, to equal Smith, and we're going to abbreviate Brothers. We're going to change the name, end the if, end the for. Here we have embedded an if-then statement inside of a for next. We could combine a switch where we are switching based on some number. Maybe it's a choice field. And for each option, maybe there's choice 1 and choice 2 and choice 3 and choice 4. And we then end the case structure. Now, in case of 1, evaluate a condition. If this, then that, or else the other thing. And that would end up looking like this. In case of 2, we might want to for I in a selection of records, and we know what that's going to look like. In case of 3, we could have a while do, and in case of 4, we could have another switch. And that switch, in case 1 of that switch, we could have another if then. And it goes on and on and on. These 4 structures, the if then structure, the switch or case structure, the while do structure, and finally the for next structure. These 4 structures are the basis for artificial intelligence. They are the basis by which computers are taught or programmed to make decisions, to evaluate situations, and act on the results of their evaluation. And these decisions and evaluations can be extremely complex, and we can represent that complexity by embedding or nesting one decision or looping structure inside of another. That's the end of our class on for next looping structures, and that is the end of the 4th class in our series of classes on looping structures in general. I hope you enjoyed this class. I hope you will join me for our next class when we're going to take a deeper dive into the select statement. We're going to look at how to use the select statement for creating charts and graphs, how to use it to create views into unrelated and unlinked tables, and we're going to continue the discussion of how to use the select statement to create subsets or arrays of data that we can act on inside of our code. And don't forget, this database and many other databases are available for you to use and download for free here at the Nioxus website in our member portal. Go to the website, get your password, log in, and at the member portal, you'll see the database we use tonight and all databases and global functions and data models and training classes that are available to you for free as you continue to advance and improve your Ninox skill set. Thank you so much for joining me in this class. I hope you enjoyed it. I look forward to seeing you in our next class when we look at the select statement. And that's going to be it for now. Have a great day. Have fun with Ninox. And I'll see you in our next training class. Bye-bye, everybody.